Yeah.
They're starting to
I was like, hey, like I can
we just talked about this.
What? The pins are out of ink.
I think it's just because of the glare.
It is. Don't we have this down?
How do they work in possible laws? I mean, we feel like public, whatever, class name, like ours, whatever it is. Like the rest of Java. Watch that.
There's nothing.
Oh, such and stuff.
Yeah, very true.
Okay.
Okay, so we are going to transition away from static methods where we don't need an object to all of our methods being non-static where we do need an object. Up to this point, we have used Java classes, the string class, the scanner class, the file class, the math class. We have written used classes that someone else has written. Now we are going to write our own classes. Does it help if I turn the light on the whiteboard?
Yes.
Yes, yes.
So it either glares for you or it glares for me. So if I turn it off, it glares for you, and if I turn it on, it glares for me. That's fine. I'll glare for you. I'll take the glare for you, because I'm a killer. Emily, were you driving on like Lincoln Street this last Saturday or Sunday, going up the hill south?
Was I driving?
Yes.
No.
Okay. Because I saw your doppelganger driving.
Oh, okay.
I was standing on the street, and somebody swerved over to hit me. I thought it was you.
No, I'm not driving.
You would have done a much better job at acting.
No class.
Okay. So remember, a class is a collection of attributes and behaviors that completely describe something. Okay. It's a collection of attributes and behaviors that completely describe something. So, what we want to do is we want to create our own type. That's what we were going to do when we create a class that has attributes and behaviors that completely describe something. We're going to create our own type. And then others can use that class if they want. Now, obviously, we'll have homeworks on this kind of thing, but I want to at least relay the groundwork. We have review tomorrow. We'll have a little lecture today, a little bit of lecture tomorrow, review tomorrow, and then Friday's our exam, and then we'll really hit this hard Monday of next week. As of today, we have 3.5 weeks left of school before our final, right?
That is terrifying.
That is terrifying, right? That's 18 days of actual class, counting the exam and everything. So as of today, we have 15 days of actual class plus 3 more days of actual class, so there's 18 days of class. I know, I feel crushed by it too. But. Okay, so what makes up a class? Number 1, no static in the methods. If I see static on the methods, your grade will suffer immensely. Are you jet-lagged at all?
Yeah.
Okay, number 1, no static on the methods. We will not have static on our methods in our class. Now, in main, we'll obviously have static on the method. In the methods class, when we're making objects and stuff like that, and we're filling an array, those will be static methods. But in the class itself, of our type that we're going to create, we will not have any static methods.
Why? Why is that so important?
What's that?
Why is it so important?
Because when you have static methods, you don't need an object. We want to always have an object when we call our methods.
Oh, okay.
Okay? Number 2, robust classes will always contain a set of methods prescribed by Java. Number 1, it will have a set of private data members, the attributes at the top of the class, and those will always be private. Okay? Unless I tell you otherwise. Number 2, there has to be a way to build an object. There has to be a way for me to build a house, essentially. Right? If you think about building a house, there's got to be some way to build that house. You got to lay the concrete, put the walls up, put the ceiling on it, that kind of thing. There has to be some way to get at the contents in that house. How many bedrooms is a house? Okay? There has to be a way to change the contents of that bedroom. The walls are blue in the house, I want to change them to be pink or purple or green or whatever color it is. There has to be a way to get the address of that house, to get the contents of that object in an easy fashion. That's what we call two-string. There has to be a way to compare 2 objects. Hey, am I equal to this object over here? Are they the same object or are they not the same object? I have 2 objects, the contents are the same, they're going to be equal to each other. Their contents are not the same, they're not going to be equal to each other, right? We have to have a way to compare them for order. If I wanted to have everybody in the room stand up and have you sort yourself, we'd typically have you sort yourself by birthday, right? Youngest birthday in front, oldest birthday at the back or whatever, or the other way to sort people naturally is by height. Everybody stand up and then sort you by height from shortest to tallest, right? So, there's that. That's what's going to be called the compare-to method. So I guess the easiest way to do this is to think about, let's write a main, and let's write the corresponding class that goes with it. So here's the question for you. Do you want me to do this on the whiteboard, or do you want me to type code?
Code.
Type it, yeah.
Yeah.
You're not going to get it, though. I'm not going to give it to you. You're going to have to do it yourself.
Yeah.
I'm not going to type code and then give you my Java files. Let me just be very clear on that. Because I've done that before, and students look at that and they think they understand when they look at my code in the Java file, and they don't. Okay? So if I type code, you're going to have to write it all down anyway.
Yeah,
Right,
well,
so-
it'd be easy to read.
What do you say, my handwriting sucks, Paul? Is that what you're saying?
Well, everybody's handwriting sucks compared to typed code.
You also
True.
have engineers
Yeah, that's a good point. Yeah.
Messy.
I bet messy, but it's alright.
My handwriting is shit.
That's messy.
Yeah.
Also, this way neither side has to worry
You
about
guys are
it.
going to make me cry because you're picking on me.
What? Neither side has to worry about where this way.
Yeah. Wait, y'all for benefits, so will you always have one in the benefit, or is that depending on what the benefit's supposed to do?
Well, that's what we're going to talk about in a minute.
Well, is it like, so if we can voice for a situation or depending on what you want to do, right?
Well, no, you're gonna have methods that do pretty much the same thing regardless of what the class is called. Okay, so let's
I
do
mean, like, there was
this.
like a class that like locked heads, some of it was void, some of it wasn't, and that was relative to what that was going to do. So that's what I think that's the choice. It's like, if your void is like, what is the purpose of this method?
When you wrote all that like A, B, C stuff on the board, do our classes need every single one or just one?
For the most part, yes. But again, it's kind of a design decision we're gonna start making now, Kyle. We know what will be in a robust class. The question is, do I want my children to be able to paint their bedrooms any color they want, right? That kind of thing. So we'll talk about it as we go along, because there's gonna be some decisions to make. I'm gonna make 2 classes here. I'm gonna make, so I'm not gonna worry about packages. I am gonna import java.util.scanner. Okay. And this is gonna be public class main, which is gonna contain the main method, okay? And in here, we're gonna have public static, void, main, string args. Okay. So in here, I'm gonna use the right characters. So we're gonna create a student class. So we're gonna say student, which is the class type that we're gonna create. We're gonna give it a name. I'm gonna call it a student, or a stu, right? Or a student, I guess. So all I've done there is create a reference, right? All I've done there is create a reference, okay? So now,
Wait, what's the name of it? What's the name of it?
it's a student class. A student is the name of the reference. Go ahead.
So this one can be static?
Main is always static.
Static, okay.
Main is always static, right? So there is no, this one can be static, main's always static, period. Okay? So a student, I'm just gonna set that to null for a moment, and then I'm gonna say student, B student, and I'm gonna set that to null. So I have 2 references for classes, for a class that does not exist yet, okay? So if I try to compile this, it's gonna say, hey, I don't know what a student is. Okay, so again, I'm gonna come over here, I'm gonna go file new Java, and I'm gonna say public class student, okay? So there's my student class. So now watch what happens. If I save this, and I compile this code will actually compile and run. Now, the objects are obviously null, but hey, it now knows that I have a class or a type called student, and I have 2 references to them, okay? So the first question we have to ask ourselves when we're writing our class is, what are the attributes, the properties that a class is going to contain? What are the properties of any student? There's 2 of them I can think of off the top of my head. Name,
Great.
and an ID number, okay? If we want to go with grade, we'll go with grade 2, and I'm okay with that, okay? So let's say there's 3 properties for this. There's 3 attributes that every student at this university has. They have a name, they have an ID number, and they have some kind of GPA, right? Now, for most of you in this class, your GPA for this class is a 0.0, but that's a different story. Okay. Right, so we're gonna do that by doing this. We're gonna say private, okay, or bait, if that is it. Private,
Wait, why are we using private now?
string name.
Why are we using
Okay.
private now?
So that's a great question, Kelly. Why are we using private now? Because we want to ensure that our data members for this class are only visible to the class itself, okay? So we want to make sure our data members in the class can only be called by objects of this class, right? And there's a fancy word for this. It's called encapsulation. Data members are private to protect them from proper use in the outside world. And the outside world is described as, or defined as, outside the curly brackets of the class. Okay? So I don't want you to be able to do anything with the name, the ID number, or the GPA outside of the object that we're going to create for that person, right? Meaning, I should not be able to willy-nilly say, Blaine, your name is no longer Blaine, it's Blainette, and I change it without your knowledge, right? We call that identity theft, and it's against the law, okay? So we do not want to be able to do anything to the contents of the object without going through that object itself, okay? Hey, Blaine, I need you to change your name. Blaine says, no, screw you, right? Or, hey, okay, I'm going to change it to Blainezina, or whatever it is, just because, you know, I have no thing to do with it. So private means, literally the word private means not accessible outside the class, period, okay? Not accessible outside the class. And that, for that meaning, not acceptable outside the class, okay, we call that encapsulation. We're encapsulating all of your attributes that you individually own inside of you, inside of your object, okay? So private string name, private, if I can spell the word private today. Private int ID, we're gonna say the ID number is an integer, and we're gonna go with private double GPA, okay? So now, if I come over here and I say, hey, new student, okay? If I come over here and I say new student, this code is going to work, okay?
Why?
Because what this says over here is I have these attributes, and so when I create this class by saying new student, these attributes are automatically going to be set to 0, null, or false depending on their type. So in this case, name will be null, ID will be 0, and GPA will be 0.0. Okay? And I can show you this by coming back here and putting a breakpoint right here. Okay? Debugging this. So notice here, a student, name is null, ID is null, 0, and GPA is 0. So anytime when the class gets loaded, and the class gets loaded by me just simply saying student A student, okay? Anytime the class gets loaded, the values of the class level variables are always 0, null, or false, depending on the type, okay? Now, we may or may not want to change those, okay? We may or may not want to change those values, okay? So first of all, we call this right here, new student, open and close parentheses. We call this a default value constructor, okay? Commonly abbreviated as DVC, which stands for default value constructor. Okay. So here's the little weirdness of Java. If I have no other constructors, I get a default value constructor for free. Meaning, hey, I didn't write crap code over here, right? I didn't write a constructor over here. I just have attributes. And since I have nothing else in this class, no other ways to build an object, I get those values as 0, null, or false for free, okay? So the purpose of a default value constructor is very simple. To change the values from 0, null, and false to something else. only if you want to, right? If you want them as 0, null, and false, then you don't need a default value constructor, okay? Unless you have other constructors. Again, I'm going to come back around to this. So this is the weirdness of Java. The moment I write another constructor, if I want them to be 0, null, and false automatically, I have to create a default value constructor. If I don't have any other constructors, then they're automatically 0, null, and false, okay? But the whole point of a default value constructor is to say, okay, I know those are 0, null, and false. I don't want them to be 0, null, and false. I want them to be something else, okay? So what we're going to do here is we're going to write this constructor. So this is a constructor. Constructors are very special in that they do not have return types, okay? A constructor is the only method in Java that does not have a return type. And I'm not talking void as a return type. I'm talking there is nothing there. The parameter is blank, okay? So we're going to write this default value constructor by saying public, because we need to use it in the outside world. We're calling it from main, so we need it to be accessible in main, and the only way for it to be accessible in main is for it to be public, okay? There is no return type, period. Don't void, don't put anything, it's just empty. The name of the method is called student with a capital S. Again, this is different from what we're normally used to doing. Method names are always start with the lowercase letter, except for on constructors, they're the same name as the class, okay? So it's the same name as the class, open and close parentheses, okay? Now, inside of this constructor, we want to change those values. We want to set a name, we want to set an ID number, and we want to set a GPA, okay? What we will not do is this. We will not say name gets, double quotes, I'm a nerd, double quotes, like so, okay? This will work in certain instances, okay? But what we need to do is the following, and I'll explain to you why. Because if we come over here, back in main, and we say student B student gets new student, okay, like so, somehow we only have one Java file called student.java, but somehow we need to disseminate between the object for B student and the object for A student. Those are two separate objects. They just happen to have the same contents in them, but they're two different objects, right? We have clones of you or clones of me, right? Two separate objects. So when we enter the class, when we say bstudent.whatever and call some method, we got to know that we're getting the contents out of the B student object or we're getting the contents out of the A student.
Wait, aren't you like calling the
Let me finish, please, okay? We need to know that we're getting the contents of the B student object or the A student object. So in the class, in the student class, we are going to preface this class level variable by saying this dot, okay? All lowercase, this dot, okay? And what that means is this dot is then synonymous with B student or with A student. When we say B student dot whatever, it says, oh, this is really meaning the object B student in my example and the contents of that object, okay? So we want to say this class level variable called name is tied to this object when we make that object call, okay? Does that make sense? Because Blaine's giving me the eyes.
I'm a little iffy on
They're
that.
the sexy eyes, but he's still giving me the eyes.
How do you differentiate between A and B?
Okay, so that's a great question. Right here, this is going to differentiate it from A by creating an object with the stuff inside of it. So anytime I use that, do something with the class, I'm going to preface it with A student dot or
Okay.
B student dot,
Not
right?
this.
That's it. That's how I differentiate,
Okay.
okay? So, this dot name gets whatever, this dot ID gets 999, this dot GPA gets a 1.0 because they're not a very good student. I'm a nerd, just really isn't a good nerd, okay? So let me show you this now let me show you what happens. Okay, I'm going to compile this. I'm going to come here, I'm going to set a breakpoint here on A student. I'm going to debug. Okay, so I'm now on that line of code. I have not declared my variable yet because I don't see it over here. Okay, but I am going to go into the constructor. Okay, so pay attention to this window right here in a minute when we come back. Okay, I'm going to go into the constructor. So I go into the constructor here, and I say, okay, hey, look, here's the reference called this. That's essentially the A student right now. And I step and I said, okay, the name now gets I'm a nerd, the ID gets 999, and the GPA gets 0.0. I'm done. I come back and I assign that to A student. So notice here, the important thing is A student is being referred to by object number 132. Okay? A student is being referred to by object number 132. I'm going to do this all again. I'm going to step in. Okay, so notice now that the object number is 139. So that's going to be the object that is associated with B student when I'm all said and done. Again, I set the stuff. I come back. And notice that A student is object 132 and B student is object 139. So what I have here is I have two objects with the exact same contents. Okay? I have two objects with the exact same contents. Now, again, this is a default value constructor. The question you have to ask yourself at some time when you're doing this is, do I need to create a bunch of objects that have the exact same contents but are different object numbers? And I'm going to represent this by this. Here's A student. A student points to an object with I'm a nerd in it. 999 for the ID and 1.0 for the GPA. This is object number 132. B student, okay, is exactly like A student. Except for it happens to be object 139 in memory. Yes, Ian.
So if you didn't use this dot name, this dot ID, etc., then they would both point to the same object?
Potentially.
Okay.
Okay? You can actually get away without using this in certain instances, and in certain instances you have to do it. Okay? So this is a great question. I'm going to tell you right now I'm lying to you. Okay? I am going to force you to use this dot all the time right now. Okay? Just because there's this weird nuance of if you have A, then you don't have B. But if you have B, you can have A. Right? If you have A, you can't have B. But if you have B, you can have A in a different context.
Okay.
Makes no sense. So sometimes I can use this, sometimes I don't need to use this. Right now, just save me the hassle. And again, this is where the wonderful phrase that we coined years ago comes in this speak. Hang on, Kyle, right? Right now it's Stu said so. Stu tells you to use this dot. You say, yes, sir. Thank you, sir. May I have another? If you're an Animal House fan at all, right? Thank you, sir. May I have another? Type of thing. That's what you're going to say right now.
Wait, so this just like, though this however makes a separate object.
Doesn't make a separate object. It just tells me what object it refers to.
Okay.
Kyle.
Is there any reason why there are objects 132 and 139? Why not just like objects 0 and 1?
Just because of the JVM, I'm sure it has other stuff behind the scenes that it has a bunch of objects behind the scenes. So, Matt.
So just to clarify, in student.java, the public student with the parentheses, that's a default constructor. So
That is a default value constructor.
So that just like when we make a new object from the student class, it just
Yeah.
automatically happens.
Yeah. Okay. Paul.
Forgot my question.
Okay. Jessica, you just question there, or you got a question? Nothing. Okay. Now, so let's confuse you. Okay.
Let's do it. Oh, I had my
Go ahead.
my question.
No, go ahead.
Oh.
So seriously, if you have a question in the middle of me talking, try and politely interrupt me, because this is gonna get confusing, and it's gonna get confusing really, really fast.
So
Go ahead.
how you're explaining like how you're making us use this?
Yes.
Is it safer like in an actual like coding setting to just use this as like a safe?
Yes, and we're gonna show you right now. Okay. Go ahead, Kelly.
Could you put like this dot whatever equals?
So how
Well,
you
can you
read
read
this,
the next
how you
one?
read this is this class level variable called name is gonna get this value.
Well, could you make it so like, please type in your name or whatever? Could you do that?
Never in the class, okay? You will never have prompts, I shouldn't say never, but strongly never, where you prompt for input in the class yourself. You wanna build the object, you wanna get all that information you need to build the object, right? So think of it this way, I need to build my house, okay? Or I'm gonna build a garage. So I'm gonna build a garage and I go to Home Depot or Lowe's or Ziggy's and I buy the garage kit, okay?
Fucking
And the garage kit has a 10 by 10 cement pad. And I get down to my 10 by 10 cement pad and I say, you know what, I really want a 14 by 14 cement pad. Well, the garage kit I bought isn't gonna work on that, right?
Oh.
Because it's 4 feet bigger, okay? So you're not gonna make those decisions inside the class. You're gonna make those decisions outside the class and you're gonna build the garage, right? I made the decision I want a 10 by 10 slab in my garage. I bought the 10 by 10 kit. I'm gonna build a 10 by 10 garage, right? I'm not gonna start building a 10 by 10 garage and say, oh shit, I really wanted a 14 by 14, which we all do anyway. But the point is, you make those decisions elsewhere and then you just build the
So
object.
you wouldn't make it in class student, but you make it in the main?
You make it in main, right? You
Okay.
make those decisions, you prompt in
And then
main.
make that too, so that it would equal the student, this thing, dot whatever equals whatever the input was for
Right.
main.
So here, what you see is a default value constructor. And again, the only point of this is name is null, that's 0 and that's 0, and I don't want them to be null or 0. I want them to be something else. Now the question you really have to ask yourself is, do I actually need a default value constructor, right? And the answer is, in this example, probably not. Meaning, I don't want to build a bunch of robots and then change the contents of those robots to give them new names and all that stuff. I just want to build the robot I want from the get-go, okay? We do that with what is called an explicit value constructor, okay? An explicit value constructor is a constructor that takes parameters. And what we will do is explicitly assign those parameter values to the class level variables. So what do I mean by that? So I'm going to change B student here, and I'm going to change B student, and I'm going to pass in,
Can you write the definition on the board?
what?
Can you write the definition on the board for explicit?
Yeah, can you give me 1 second, Mara?
Of course.
Okay, so I'm going to create a constructor. This is called an explicit value constructor. Typically, we refer to it as the EVC, explicit value constructor. And the point of the explicit value constructor is to create the object with explicit, aka not generic, values that will be assigned to the class level variables. So in this case, name is not going to be I'm a nerd, it's going to be Stu Steiner to start with. Okay? ID is not going to be 999, it's going to be 666 because I'm the Antichrist. Okay? And I'm way smarter than anybody in the room, so my GPA is a 4.5, not a 4.0. Right? Or 10.5 or whatever you want. Right?
Explicit value constructor restricted whatever you want to find variable at.
So how this is going to look is this, and I'm going to do it the wrong way first to show you why we're doing things the way I've been having you do things. So I'm going to say, okay, string name int ID double GPA. Okay? And so this is one of those examples where if you don't use this, I want to show you what happens. So I'm going to say name gets name ID gets ID, and GPA gets GPA, okay? Just like so. So in this case, this is wrong. I'm telling you this is wrong. I didn't use this. Now up here, I'm gonna come along and I'm gonna get rid of this is up here, just because I want to show you this. Again, you'll always put this, but right now I'm gonna take them off. So I'm gonna compile this code, okay? And I'm gonna go back to main and I'm gonna do my debugger here, okay? So notice here, I step in here. Again, watch this stuff right here. So notice that the name gets I'm a nerd, the GPA gets 999 or 1.0, whatever, right? We come back and the contents of a student are I'm a nerd, 999 and 1.0. Everybody can agree with that, right? That makes sense, okay? Watch what happens now when I call the explicit value constructor. Same game, I'm gonna step in here. Okay, so watch this right here now, okay? Here's the arguments coming in. Notice what they are right here. So, notice what didn't happen.
The
Didn't
variables
assign
were
anything.
They did not change. These did not change. These are the class level variables. These are the local variables, okay? Without the word this here, what this says is the name being passed in is assigned the name being passed in, okay? The only way for you to get this to work properly is you must preface the one on the left of the assignment operator with the word this. This dot, okay? This dot, this dot, like so, okay? So again, I'm gonna debug this bad boy. I created this project and I never put anything in it, hang on. Okay. So here we go, I'm gonna debug, come in, again, notice, know this, but it still changes everything fine, right? Default value constructor, technically don't need this, it will change those class level variables for me. Here though, for these to change, I need this, right? So as I come here, step out, step in, now watch these variables right here in green, changed, 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 because what this is saying is this class level variable called name, this class level variable called name is going to get the name I passed in, okay? The way to prevent ourselves from making this mistake and having to understand when we need the word this in front of stuff and when we don't need the word this in front of stuff is what I've been teaching you all along, and this is where it comes in handy now. If I do this, final, so very learn how to type, final string name, final int ID, final double GPA, okay? And I get rid of the word this here.
Like this, so this and final cannot coexist.
So what this is going to say now is, hey, this does not refer to the class level variable, it refers to the variable called name. You cannot have this variable being passed in on the left-hand side of an assignment operator. So this is why we've been doing final all along, just for this moment. When I try and compile this code, okay, notice it stops me. And it says, hey, I have no idea what the hell you're trying to do here. If you're trying to set a class level variable, you're doing it wrong. That's what the compiler's telling you. I've been doing final on parameters and forcing you to do final on parameters for this moment, because this is the moment that it says, hey, I can't do this. I need to have this dot in front of it. Now when I put this dot in front of it, like so, now this code's going to compile, because it's going to say this class level variable called name is going to be assigned the value of the name being passed in.
So final and this coexist, is what you're trying to say.
Final is required on everything. Oh.
I know, but final and this can work together.
So now when I debug this, Okay? I know that one works fine, right? But now notice here when I do this, notice that again, it sets the class level variables to the value being passed in. If I forget the word this, it's not going to compile. Okay? So now I look at B student and I have a different name, a different ID, and a different different GPA than I do from the default value constructor. Okay? Everybody okay with this? Because this is just 2 of the 8 methods we have to ultimately write.
So we do have to use fun.
We have to always put final on our parameters coming into a method. We should be doing that now, Jacob. There shouldn't be any question about whether or not we're going to ever pass a parameter with final on, right? Every frickin' assignment I've written from this point on, when we got to method, said all parameters will be passed as final, right? You've all just ignored that. Well, now you can't. Go ahead, Paul.
So pretty much every value that's being passed in is final.
That's correct.
And if nothing's being passed in, does it not matter?
What's that?
If nothing's being passed in, does
If
it
it's
matter?
not being passed in, it doesn't matter, right?
Okay, yeah.
But parameters being passed in will always be passed in as final. And all that means is it just can't be on the left-hand side of an assignment output,
Mhm.
right? I don't want to have to make the decision on, do I need this or not need this? Right now, we're just going to say I need this on everything. Okay, so now, I want to go back to a moment here. I want to comment this out. And I want to come here, and I want to comment out all of this code for 1 second, and I want to explain this to you one more time, okay? So, without any constructors, only class level variables, without any constructors, right? I have no constructors, I only have class level variables and student, okay? I, by default, get a default value constructor for free. What that does again is it sets my class level variables to 0, null, or false, okay? The moment, however, though, I write another constructor, the moment I write another constructor, in this case, I'm going to uncomment out the explicit value constructor. The moment I write another constructor, then I no longer get a class level or a default value constructor for free. So notice here, when I try and compile this, right, I only have a explicit value constructor and student. When I try and call a default constructor that I have not written, the code's going to say, hey, you don't have a default value constructor. Okay?
And me to make it.
So the moment you make an explicit value constructor, you have to ask yourself, do I need a default value constructor? Okay? Remember, the only point of the default value constructor is to make lemmings that are all the exact same, right? Typically to change the class level variables from 0, null, or false, but every object you make with that default value constructor is going to be exactly the same.
And it's
Okay.
a free per.
In this case, I'm going to say, we don't want to make a bunch of lemming students. I don't want every student in here to be called I'm a nerd 9999 and a GPA of 1.0. So I'm going to say, hey, we don't need a default value constructor. I'm not going to make it, and I'm not going to call it over here. I'm going to only create and call an explicit value constructor. Okay? By the way, though, and this is a very important concept. Remember the whole BMI debacle and the get info and that whole thing, right? Or the read info? We had 2 methods called read info. What did we call that? We had the same method name, same class, different parameters.
Yeah.
Overloading?
Method overloading. Constructors are a version of method overloading. Okay?
Okay.
I can write 3 or 5 more constructors or whatever I want here. I can pass in the ID number, then the name, then the GPA. I can pass in a constructor with the GPA, the name, and the ID number, right? As long as the parameters are different with the same name, I can do that. Why would I ever want to do that? It's just options, right? At this juncture now, I'm saying, hey, you're going to build a house. Are you going to build it by doing the name first, the ID second, and the GPA third? Or do you want to do the GPA first, the ID second, and the name third? Kyle.
So, like in this example, we're just doing like student A and student B. If you wanted to do something with like 1,000 students in the name, you have to like write out 1,000 statements.
So what we would typically do in that case is read the information from a file and put them into an array, which we will eventually get to, Kyle. Other questions? Okay, so I'm gonna say, hey, we don't wanna ever build a lemming student, so I'm gonna get rid of the default value constructor. Meaning, if I'm gonna build a student, I must call the explicit value constructor, passing it the name, the ID number, and the GPA. So in this case, thinking on Blaine today, Blanina.
Wait, so you don't only create the standard one, but where it's like all one values. That's like case by case, right?
So, well, it depends again, it's a design decision. I'm
Yeah.
saying, hey, we are never gonna create a default student. Any student we create is gonna have a unique name, a unique ID number, and a unique GPA.
In that case, you don't want it, but if you want
Right.
every value being exact.
So now, when we create A student and B student, A student's gonna be Blandine again, with the ID 1, 2, 3, 4, and a GPA of 5.0, and B student's gonna be Stu Steiner 666 with the ID, with the GPA of 4.5, right? So I will have two separate student objects, which is what we have in real life. Blaine's his own object, I'm my own object, right? We will pick up with a little bit of this tomorrow. This will be on the exam. Constructors and two-string will be on the exam, I'm gonna tell you right now. Okay? We will talk about printing this out tomorrow. Printing out the contents of the object tomorrow with the two-string.